So in these sessions, I'm willing to show you through some different hands-on sessions and demos how to, let's say, easily start an evaluation and development of a Bluetooth low energy application over STM32WB0 series, thanks to the associated powerful STM32Cube ecosystem that I assume you are familiar with. Now you've got a clear understanding that STM32W0 is not only a single device, but a set of devices, so a family. So that's why during the session, we will play using different evaluation boards. During each session and prior to each session, for sure, we'll highlight the needed material you will have to collect and in order to replicate at home the session, okay? So this is the agenda that are really emphasized by Yvon. So we'll go through some software demo, okay, where we will show you how to easily start development from basic beacon, BLE profile, extended, let's say, features such as periodic advertising response, and how to add BLE easily to an existing device. And then on top of software aspect, our colleague Laurent will go through some hardware topic, because building a Bluetooth low energy application is not only a matter of software, but as well a journey in terms of hardware. Okay. So again, during the sessions, okay, if you are interrupted or you need to do something, there will be still on the top left corner of your screen this where we stand logo, okay, that will allow you to know, okay, where we stand, okay. So will allow you to know where we are in this workshop session. So we'll start now first with a basic exercise using STM32CubeID and associated CubeMX to build a basic beacon. So what we'll do here, the idea would be first, and maybe some of you are already more than familiar with Bluetooth low energy concept, but we'll demystify a bit and try to understand what is a BLE beacon, okay? We'll go through the concept itself. And then using STM32CubeID and the CubeMX, we will import a basic beacon sample code, part of the package. We'll browse the code, go through, try to understand the theory versus the code implementation, and then we will scan and discover our beacon, okay? So in order to play with, you will need STM32CubeID 1.16 release, the one supporting the WB0 release. You will need as well a debug BLE application on your smartphone, and here we will use BLE scanner. Of course, we have in-house a powerful debug application named STBLE Toolbox that Sebastian will use later on. We will use BLE scanner just because a matter of look and feel when you will display the beaconing, okay? And you will need, of course, a board on your desk, okay? Exactly the one I have here on my desk, which is a Nucleo WB05, which embed the STM32 WB05. Why 05? Because you understand that WB0 is a family. WB05 is the first entry level, so really driven by the price, with a few amount of flash and RAM. Definitely tailor and fitted such kind of tiny application beacon, which are not so demanding in terms of flash, RAM, and MIPS. So let's move on and let's start this first hands-on and demo. First of all, let's try to understand what is the BLE beacon. What is a beacon? I'm pretty sure and convinced most of you are familiar with the concept, but before playing with, let's try to understand a bit. So the BLE beacons application take advantage of what we call the advertising Bluetooth low energy mode, which is the state that allow to broadcast data over the air, okay? So advertising mode is the mode that allow to push data over the air. And it allows to push for some data over the air using a periodic timing, okay, that we will call the advertising interval, which is specified, okay, which is from 20 milliseconds up to 10 seconds, okay? And this advertising data are pushed, so at each advertising interval, over the 3 legacy channels, 77, 38, and 39. Here I'm dealing only with legacy advertising, okay, because BLE Beacon are based on legacy advertising, and for sure, WB0 supports advertising extension. And by the way, we'll see this later on during the periodic advertising with response demo. So a beacon used the concept of advertising interval to push data at some specific timing over the air, and the smartphone which is scanning, the client which is scanning, is able to collect the data. And what are the data we have to push over the air? Here again, as we are talking with legacy advertising, the advertising data payload is up to 31 bytes. And here the specification will tell you that you can push for what you want over the air, okay? The temperature, a name, what you want. The only thing that you have to specify is that prior to each data you are pushing, you have to specify, you have to prefix the data with an advertising type. And those advertising type are part of the specifications: local name, manufacturer data, service UID data, okay? So again, a BLE Beacon reuses the concept basic of advertising. I'm pushing at specific interval over the air some data, and the data I can push for what I want. I just need to prefix the data with an advertising type. Now, what is the magic behind? Each type of beacon, and here I'm just naming the more, let's say, notorious one, so Eddystone from Google, iBeacon from Apple, are basically defining and customizing the data that you push in the frame, which at the end give a meaning to the data themselves, okay? So again, a beacon use advertising concept. The only thing is that Eddystone, iBeacon are just specifying the data you will push that will give a meaning to the data, okay? So if we took a basic example, I do have my Eddystone or iBeacon, let's say, placed in a retailer store, okay? They are broadcasting data over the air. Smartphone in my pocket is basically scanning, okay, in background or with a dedicated app. Then the data are pushed over the cloud. As the data are compliant to Eddystone or iBeacon, let's say the cloud server is able to interpret the data, okay? Typically, okay, I know that you are quite close to a shoe shop, typically. And so the cloud server retailer will push you some advertising, pre-sales, promotion, and so on. So this is the concept of the beacon, based on some basic beacon and tiny small device, pushing data over the air, which are specified, so at the end, the data get a meaning, and you are able to receive on your smartphone some positioning, promotion, resales price, and so on. So this is the idea of what is a beacon. So we'll start to play with. You are, I'm quite sure, familiar with the STM32Cube ecosystem. And if you are not, okay, please enjoy. You will see how to it will simplify your journey. Using STM32Cube ecosystem, there is 2 tools, CubeID, the one we'll use that integrate for time being STM32CubeMX. And from those tools, okay, you can start to build an application either at chipset level, you start from scratch, your own PCB, your own device, at board level, or at example application. And this is what we will do. We will start at application, okay? So the idea is that we will build a beacon using CubeID, importing the beacon code on our local repository. Before starting, just a word about some things that you might experience during your prototyping and evaluation regarding WB0. Let's assume you start to play with WB0 series, you flash an application, and at some point, you are no more able to wake up the device and to take control over the G-Link, the ST-Link probe, okay? And this is expected because WB0 has been really designed for low power optimization. There is so no capabilities to wake up the chipset from the SWD port. Okay, so you will not, assuming you have already flashed an image which enable the low power mode, you will not be able to wake up the device back, okay, using the SWD probe over STM32WB0, Kyle, IRR, or whatever, okay. You will have to force the wake up of the device using an IO wake up capability, which is, by the way, that's why there is a jumper on the board. Okay, as you can see here, there is two positions that allow to force the wake up of the device. Okay, so if we look at the board on my screen, okay, typically there is a jumper that allow to move, let's say, to a position that allow to force the wake up of the device. Okay, so now you are aware and we can start. So again, in order to play with this demo CubeIDE, CubeMX that we will open from CubeIDE, NucleoWB05 and BLE scanner. Okay. So let's start, and let me first open STM32WB0. So let me open the tool. Okay. So I'm pretty convinced you are familiar with the tool, and what the tool will ask you first is where are you willing to place and locate the code example we are going to copy. So I will use the default workspace it's asking, and I launch the tool. Okay. The tool, if you are not familiar with, is okay, a free IDE first, and a way to browse all the ST portfolio for first the parts, but as well the Nucleo board, and as well all the sample code. Okay. So tool is now open. Okay. And what I'm willing to do is to start from a code example. So I will go to File, New, STM32 project. So I want to create an STM32 project. So I open. So the tool is initializing the full database. So in short, offering the capability to select any chipset, any Nucleo board, or any sample code part of the STM32Cube ecosystem. So it's pretty huge database, so it could take a bit of time to open. So here we are. Now it's open. Okay. So it's open. I want to start from an example. Fine. So I will click here to example selector. So it's browsing the full database, and now I should get the end. Okay, so here, as you can see, it can take a bit of time because it's browsing the full database. So now, okay, I've got the end, and what I want to do is that I want to use the BLE Beacon application. So I select BLE Beacon, okay. And so the tool is, okay, I'm looking for BLE Beacon. The tool is offering me, okay, BLE Beacon sample code is supported over this full set of Nucleo board, okay, from the, let's say, IM-WBA, okay, which has been launched this year, by the way. So Nucleo WBA, as well the formal dual core WB, and now the new series WB0. And I want to select, okay, the low end of this WB0, the low price one, so the WB05. So I select WB05. Okay, the tool will say me, okay, you need, okay, at least one CubeIDE 116. This is the case, and the part mounted on the device is WB0. Okay, so now I want to import the code on my laptop. So I click to next, and then, okay, I'm copying the BLE Beacon sample code to my local repository. So copy is ongoing. Okay, and now copy is over. Okay, so I do have now on my laptop the sample code here. Okay. So before flashing, before building and flashing, okay, let's have a look first about what is inside the source code. So you will find, of course, all the driver that you will find on all STM32 general purpose microcontroller. Okay, so you will find as well the BSP, the CMSIS, and the drivers. You will find in the middleware, of course, the BLE stack, okay, which is needed to advertise, to be connected, and so on. You will find some utilities, okay, the sequencer, the low power management, like any STM32. And this is our focus, you will find in user section, in STM32 BLE app, you will find in this file, appble.c, you will find the initialization of your application. As we are dealing with Bluetooth low energy device, okay, one part of the initialization is the stack initialization. Okay, this is done in BLE init, okay, where we do have the BLE stack init, okay. But this is where as well I will set typically the output power of my device, okay. I can set the output power, okay, 0 dBm, -20, or up to 8 dBm, okay. So I will set here the TX power level and so on. Now, what we are willing to do here is a BLE Beacon. So we know that basically what we do have to initialize is a payload, an advertising payload. So browsing the code a bit down, okay. I will initialize my application BLE code here in appble init, okay. And here, as you can see, there are different configurations. Pending to this flag config beacon type, okay, we have the capability with the sample code to build either an iBeacon, Apple, or Eddystone beacon, okay, from Google. I will use Eddystone, okay. So let's have a look to this beacon type. For the time being, the beacon type is iBeaconing, and I want to choose the Eddystone. Okay, I move to Eddystone. Let's move back to the code. So if I move to Eddystone, okay, then I will process the code to, okay, how I will initialize my beacon, my Eddystone beacon. Okay, and here we are. So in Eddystone URL init, okay, the way I have to initialize my beacon. And here what we need to look. First of all, the first procedure that allows to put the device in advertising mode, saying, hello, I am here to push data at specific advertising interval, which are specified here, okay? And the second point, which is our focus, is that I need to specify the data I want to push over the air, okay? And the data I want to push over the air are part of this URL service data, okay? I want to push some data at specific interval, and the data I'm willing to push are the one here, URL service data. Let's have a look to the data. Here we have a table, okay, a basic array, okay, that you can customize. But if we want to respect the Eddystone URL data, we need to use the dedicated flag, okay. As you can see, the data which are set here are always prefixed with some type, with some flags. The first one is the AD type flags that is mandatory and say I am a BLE device. And then it's up to Google that they say, okay, then you have to put AD type service UID, which is AAFE. That means this is an Eddystone URL. And then behind you have a flag to say that, okay, now I will push the data, the URL I want to push over the air, okay, which is set here, okay. So again, here we are dealing with a table which need to be fit in 31 bytes, again, because we are dealing with legacy. And I need to fill this table. If I want to be compliant to an Eddystone URL beacon, I need to use exactly the same framing, okay, and the same advertising type. Now, the URL I'm willing to use is this one, which, if I'm not wrong, is defined there. If we go there, it's www.st.com, okay? So I have set the advertising, I have set the payload, okay? Now let's build. In order to build, you have to click here on the hammer. I'm pretty sure you are familiar with, okay? So how the code is building Oh, and this is live demo. I made an error somewhere in my code. Okay. I made an error by mistake. What I have done. Okay, in my type, I have copy paste something wrong. In the type, which is there, okay. Okay. I make a cut and not a copy paste. So I'll rebuild again. Okay. So build is on
this is really a live demo, huh, Dominic?
Yeah, this is live. I made a cut rather than a copy paste. And you see, okay, this is live. Okay, so now the code is on the build. Okay, so on my desk, of course, I've got the Nucleo and my smartphone with the BLE scanner app. Okay. But first of all, I will have to connect the board, of course. Okay, so I'm connecting the board. Okay, so board is connected, and now, okay, I will flash. In order to flash, I just need to click here on the arrow here. Okay. Okay, yes. The build is done. I'd select this one, and we flashed. As this is the first time I'm flashing, the debugger will ask me, okay, what are you using? I'm using ST-Link, apply, okay. And okay, I will take control on the board, okay, and I'm flashing the board, okay. So flashing in on the way. Let me display back now this. I will as well display my smartphone here. I'm doing a mirroring of the smartphone, okay. And if I open BLE scanner, okay, just reset the board, okay. And if I do a scan, you see that here, okay, I see my Eddystone device, okay. So from the smartphone app, I'm able to see the beacon, which is an Eddystone, okay. And what I'm able to see, okay, there is an URL which is pushed over the air on which I can click, and I'm clicking on it, and indeed, I'm able to browse to st.com, okay. So this is, in short, how we succeed in few clicks to build a BLE beacon, okay, and to see it using BLE scanner, okay. So what to keep in mind is that we have been easily able to build a BLE application over STM32WB0, okay, thanks to the powerful ecosystem, the STM32 Cube. And on top, okay, just need to highlight that this family has been designed for low power. So typically, if we consider a beacon, okay, power average consumption, a device which is advertising 28 bytes, okay, every 3 seconds at 0 dBm, we will consume 5.1 microamp. So definitely WB05 is designed for such kind of, I would say, small light application, which are not demanding in terms of flash and RAM.